All right. I believe we are live, Mike.
We are
It says we are
live.
live. Welcome, everybody, to the very first episode of Saving the Universe with ChatGPT. I am Matt. Or Knuckles. You can call me Knuckles. And my co-host is...
Broadband.
And
I am Broadband of Broadband Studios here as a co-creator for Saving the Universe.
And the whole purpose of our podcast is to give people some insight on some of the conversations that we like to have together, and maybe somebody will be able to do something with them.
Maybe chime in.
Yeah, chime in. Definitely chime in. Comments, more comments, the better, because we'll be able to interact with each other, build a community of like-minded people who maybe we could save the universe together with ideas, connect with people with the means to put some of these plans in action. Maybe they won't be good plans, maybe they'll be terrible plans, maybe we'll destroy the world. I really hope not, but who knows how this will go. And that's Lola. Welcome, Lola, to the stream. So today, my friend and I, Mike, we're talking about Mars. And in our discussions, we've been discussing Mars's atmosphere and Mars's electromagnetical, like the core of Mars and the magnetic field that we have around Earth and the one that we've got around Mars. So we've been doing some research because we like to solve problems, and we've come across some interesting topics regarding how to restore the atmosphere on Mars, and some interesting things to restart Mars's core. I don't know if Broadband is occupied, but maybe
I'm not occupied. I'm just resituating myself.
Give us a little insight onto some of these topics that we've been discussing today.
What was that? I'm sorry.
I've just been kind of laying out the history of our conversation today that we've been having, Mike. You know, about Mars and the atmosphere and the magnetic.
To start off with, Mars. Mars is smaller in mass, as everybody knows. And due to this fact, we need a magnetic field capable of not only retaining an atmosphere capable of making life possible on Mars, but also to help protect it from, the rays of the sun and all of the things that could kill life that our magnetic field helps with. So, in order to do that, we need to heat up the core, and we need to, create a mantle, convection currents, and, that's how the magnetic field will sustain itself. And me and Knuckles have been talking, and we've come up with a few different ideas, including a railgun that, basically takes an object and it makes it go faster and faster and faster and faster until it basically, creates enough speed for an impact on the Martian surface to mimic that of an asteroid impact, to maybe rekindle the heat that is created by an asteroid impact.
And the heat, the impact, the kinetic energy from the impact is what, the kinetic energy would create the heat. It would potentially penetrate through the crust and through the mantle and disrupt some of the potential chemicals maybe within the makeup of Mars, and also potentially reignite the core itself with the heat from the kinetic energy.
It's almost like we have to destroy the planet in order to save it.
We're like slapping somebody who's acting real crazy, and you gotta knock some sense into them. It's like, Mars, what are you doing, bruh? You gotta start spinning again, man. Look, you're losing it. There's more to live for, Mars. But one thing you said in this conversation already, Mike, that I didn't know. You said Mars has got a smaller mass than Earth?
Yeah, so
it's smaller than Earth?
It's way smaller than Earth. It's like
Whoa,
bigger
man.
than our moon, but smaller than us.
I did not know that.
Yeah.
Like, my entire 41 years, I didn't even, for some reason in my head, I've been thinking that, like, Mars was the size of Jupiter for some reason.
Really?
It's crazy, I know. Like, I think of a lot of things, but for some reason, I thought Mars was a lot bigger than that. So, now thinking about it, like, it definitely wouldn't, like, we should be able to heat Mars up really quickly in that respect. Like, technically, wouldn't we be able to just build a giant outer space microwave oven, just put it right in the middle, and then close the door and, like, put it on defrost or something?
There's this concept that was done by some guy. I forget who it is. Maybe we can ask ChatGPT about it, but the concept is that with black holes, because at the very end of the universe, if humanity were to survive at the end of the universe, there would be no stars to, get our energy from. So what we're left with is black holes. And did you know, by the way, that black holes spin? At least some do. Some of them spin. And so there's this idea that if we were to take these giant mirrors and put them around the black hole and then shoot gamma rays into the black hole using a powerful, gamma ray device, and it would go bounce around all these mirrors and spin with the black hole, and it would start going faster and faster and faster until if you opened up one of the mirrors, it would create a lot of energy, so much that it's almost like you're cheat coding the universe. It's like you're using the cylindrical force of the black hole to create more energy than what you put in. And so what I was thinking was, what if you took these mirrors and you put them around a planet and you did the same thing? What if it heated up the planet? I mean, you wouldn't be creating energy like you would if you did it through a black hole, of course, but you would heat up the planet. And that's just one of my ideas. What do you think, Knuckles? Hello?
My microphone was muted for some reason. I'm sorry. So basically, you're talking about creating a mini grow-up. Well, not a mini, a giant grow-up in outer space, like people used to do to grow weed in their closet. They line it with tinfoil, right? And
or Mylar.
Or yeah, exactly. And then they put the lights in there, and it helps with the grow
reflection
up.
of the light.
So let's see, the concept of mirrors. Who created the concept
Of putting
of
mirrors around a
putting
black hole
mirrors around black hole?
and shooting gamma rays into the black hole?
Let's find out that. So, the concept of using mirrors or other reflective surfaces to direct energy into a black hole, particularly gamma rays, is closely associated with the work of physicists like Kip Thorne
That
and other
sounds like the one.
researchers in the field of theoretical astrophysics. The idea is part of the broader theoretical explanation of how to manipulate or interact with black holes. So Kip Thorne said, work on black holes and wormholes. Kip Thorne, a renowned theoretical physicist, has made significant contributions to our understanding of black holes, wormholes, and the effects of extreme gravitational fields. His work includes exploring how black holes can be studied and potentially manipulated. He wrote a book and theoretical work. The speculation, the Hawking radiation, the idea of using energy to interact with a black hole might be related to Stephen Hawking's theory of black hole evaporation, where black holes can emit radiation due to quantum effects near the event horizon. Although Hawking did not propose using mirrors to focus gamma rays into black holes, the concept of manipulating energy around black holes is a natural extension of his work.
So ask ChatGPT about black hole bombs.
Oh,
Who
explain.
created the concept of black hole bombs?
Explain the concept of black hole bombs. So, the concept of a black hole bomb is a theoretical idea in astrophysics and gravitational physics that involves the interaction of black holes with specific types of fields or waves, potentially leading to significant amplification of energy. The idea is often discussed in the context of black holes and their interaction with various types of perturbations, I guess. Perturbations. Black holes can be perturbed by external influences such as electromagnetic waves, gravitational waves, or other fields. These perturbations can create complex interactions with the black hole's event horizon and its surrounding space-time. Super radiance effect. I think this is what you might be talking about. The super radiance effect occurs when the hole extracts energy from incoming waves, leading to amplification of the wave's energy. Is
Very
low
interesting.
rotational frequency of the black hole's event horizon. Yeah, that's pretty much what you were discussing earlier with the mirrors and the gamma ray. And
So-
Hawking radiation analogy, the super radiance is analogous to Hawking radiation, where black holes can emit radiation due to quantum effects near the event horizon. Oh, it tells us set up the mirror effect, like you were talking about. The idea involves surrounding a black hole with a mirror, or reflective boundary, which could theoretically be achieved by placing a reflective surface or field around the black hole. The setup is designed to trap the amplified waves and prevent them from escaping.
Yep.
Well, it's intriguing. So how do we convert that theory of a process into making Mars core, like melting the core, so it becomes active again.
Well, we're talking about taking a reflective surface and shooting energy into that reflective surface from the inside or into the inside, and it bounces around, creating heat, which in turn will heat up the planet, which in turn will heat up the core.
Theoretically.
Theoretically.
But what do you think would happen to the surface of Mars?
I think it would start
Right?
to heat up and melt, and it would
But
take
what
any
damage
trapped.
would it do? Wouldn't it kill whatever living organisms, microorganisms are on the surface? Because recently they did say that manganese or
Manganese.
manganese. I got some weird names. I tell you, they just name them some easier things to say for one. So, but they did find manganese on the surface of Mars, and they also found out on Mars that 21 miles below the surface there is basically enough water, if released to the top of Mars, could cover Mars totally. I don't know how deep they said. We probably could look up that article in a bit here, but it's sort of like, it's not like a flowing river, but it's trapped within porous material, but it's enough water that if it was collectively together and released to the top would cover the surface of Mars, which is interesting, right?
Yeah. You know what got me thinking is, if we killed the microorganisms that are on Mars, if we heated up the planet to the point where it sterilized the planet, then those sterile conditions might actually be what we're looking for when we're putting our life, when we're transferring our life on Earth to Mars. Because, what if there are some microorganisms on Mars that are deadly to us? Because
wouldn't we have found them by now through the tests that have been run?
not unless we were looking under the surface. I mean, if there's enough water under the surface to cover the entire planet, I mean, there's probably microorganisms on there we haven't even seen, because we haven't gone under the surface. We're only scratching the surface with our little rovers and our little
Right.
objects that we're using to, even explore the surface, but burrowing deep into the surface, we might find life that we haven't even seen before. Microorganisms or fish or whatever.
I doubt that there's fish, that's for sure. You think it'd look like the Simpsons fish?
Maybe. I mean,
with 3 eyes.
It might not have like multiple eyes, but definitely a way to explore its surroundings and, find its food. I was also thinking about this too. The surface of Mars is actually covered, I think, in silica or something. It's very, very toxic.
Right. Yeah, it's toxic to humans. Yeah, 100% it is. Yeah, it's covered in silica.
And that would be an issue that we would have to tackle as well.
Right? Is it that stuff that we get in the packs that when we buy new shoes? Those little packs. I think it's silica, actually. Those little silica packs that we get
it's toxic
in our shoes, right?
It's toxic to breathe, even.
So, did that come from Mars? No, we got silica on Earth, I'm sure.
What's ChatGPT say about the silica on Mars?
What is silica on Mars? Let's find that out. It's a little educational. So, silica on Mars refers to silicon dioxide, a common mineral that can be found in various forms, including quartz and other silicate materials or minerals. Understanding the presence and distribution of silica on Mars is important for several reasons, including studying the planet's geological history, its past habitability, and its potential for future exploration. Quartz on Earth, quartz is a common form of silica. On Mars, however, silica is typically found in different forms, such as opal or a less crystalline form of silica, and other silicate minerals. The opal, geological history, the presence of silica can provide clues about Mars' geological history. Silica often forms in environments with liquid water, right? So finding silica on Mars suggests that the planet had a wetter past. Well, that solidifies even more that, the findings of water below the surface, and then the manganese that was found, and the silica. The water definitely was present on Mars, right? So Curiosity rover, NASA's Curiosity rover, which landed in Gale Crater, has detected silica-rich deposits. The rover's findings include evidence of hydrated silica, which is opal, which points to past water activity in the region. And the Opportunity rover, which explored the Meridiani Planum region, also found silica deposits, and the findings were associated with the planet's past environmental conditions. Yeah, so with the dangers, so we wouldn't be able to go there and just take our space helmets off, right?
Right.
And breathe the air. So how do we solve that issue?
I mean, maybe we could take a genetically modified algae or a genetically modified organism capable of eating the silica on the surface and producing oxygen or something that would help support life as we know it here on Earth.
Is there an algae that eats silica?
I don't know. Let's ask ChatGPT.
Let's ask ChatGPT. Is there an algae that
or
eats
moss
silica? I think I spelled algae wrong. I think it's ALG.
ALG.
I think it's AE, not EA, but I could be wrong. And you're right, Mike. There is certain types of algae that, certain types of algae, particularly diatoms, have a unique relationship with silica. Diatoms are a group of microalgae known for their silica-based cell walls, called frustules, which are intricate and can be very beautiful under a microscope. Cool. Silica shells, frustules.
So they're like living opals, almost.
Wow,
right?
That's cool, right? So could we send those? Can we send those to Mars to help clean up the silica issue for better human habitation? Let's see what they say. Sending diatoms or similar organisms to Mars to manage silica levels is an intriguing idea, but it comes with numerous challenges and considerations. Here's a breakdown of the feasibility and potential issues. Survival and adaptation. Extreme conditions. Mars has extremely cold temperatures, low atmospheric pressure, and high levels of radiation. Diatoms and other microorganisms would need to be genetically engineered or adapted to survive these harsh conditions. Nutrient availability. Mars has very little liquid water and a different chemical composition compared to Earth. Ensuring that diatoms have access to the necessary nutrients and conditions to grow and function is a significant challenge. Okay, so we've got the algae that can eat the silica, but we've got some extreme conditions that would pose a challenge to these diatoms from surviving.
So we take like a balloon that has a reflective surface, like we were mentioning earlier, and surround the planet with this balloon, and we basically heat up the surface so that the algae can survive, and it would help protect.
Are you talking about wrapping, pretty much wrapping, or putting Mars inside of like a thermal blanket balloon?
Kind of, yeah. And we're talking about, saving the planet from like all the harmful rays of the sun that don't come to Earth's surface because of our magnetic field and because of our atmosphere. And we create conditions capable.
Do that?
How would we even do that?
Well, that's the thing, right? Like, how much material would you need to make a thermal blanket balloon that encapsulates Mars?
I would suppose that it would have to be
inflate it.
I would say it would inflate itself using the solar wind, but that's just me.
But I don't think solar wind is actual wind, though. I think it's more like heat waves, isn't it?
Yeah, but we could use a thermo, blanket, whatever you called it.
It would be those emergency blankets.
Yeah, it would activate using the energy of the sun and all of the rays and stuff. So we have a concept that there's a thing called the Dyson swarm, and
is that similar to a Dyson sphere?
It's similar to a Dyson sphere, except instead of being an entire sphere that encapsulates the whole sun, we're talking about a swarm of satellites that form kind of a donut around the sun, and that basically we could use like
energy.
It absorbs the sun's energy, and we can direct that energy to anywhere else in the solar system.
Okay, so but are we that advanced right now that we could create enough of those satellites to do this?
Well, I think we have the technology capable of creating such a large megastructure composed of satellites.
But what about the degradation or the metal that these satellites? How close do these satellites have to get to the sun in order to stay orbited around the sun in a way that, wouldn't the sun's gravity sort of pull these satellites towards?
Not if they're moving fast enough. I mean, if a satellite on Earth moves slow enough, it's going to slowly come back until it crashes onto the surface. But if you make it move fast
Yes.
enough, I mean, when we send satellites into the Earth's orbit, they're
Yeah,
not
but they're not
moving.
even
They're
in
not.
they're not even in outer space though. That's the thing. They're in
Yeah,
the upper what do they call it?
stratosphere.
Yes, yeah, exactly. They're not exactly, and yeah, you're right. They are slowly falling down, right? Like they're not
Well, they're not
just.
really falling down. They're moving at a fast enough speed. It goes something like this: you take a baseball, you throw it, it eventually comes down. But if you throw it at just the right speed, it's going to continue to go around and around and around. So it's all about speed. It's all about the force at which an object is going versus, everything else. And so these satellites are going to be moving at such a speed that they're going to stay in the orbit of the sun. And as I was saying before,
But wouldn't mass have something to do with that?
not really. I mean, if something goes at enough speed, it'll continue to stay in orbit. You know what I mean?
But it would have to be a certain amount of distance from the sun to begin with, though, right?
Yeah, to begin with.
Because if you get it too close, then the sun, no matter how fast it's going, it's just going to go in a circle until it gets into the sun.
Right. And, but we're talking about a megastructure made up of individual satellites that maybe are made up of mirrors. And of course, these satellites would have to be very compact starting off. When let's say we took Mercury and we took that planet and we started to deconstruct the planet little by little using automated robots capable of mining the surface of the planet and turning the minerals into satellites. The energy of the first satellite would be used to make the second. And then those two satellites would be used, the energy would be used from those two satellites to make two more. And then those 4 will make 8. Those 8 will make 16. And it will gradually, make more and more and more until 10 years later, and this is theoretically, of course,
right?
10 years later, you have a donut-shaped megastructure around the sun, and it's taking the energy and it's storing it, and then it's projecting that energy elsewhere into the solar system. We could use that same.
Does Mercury have everything needed to construct these satellites?
Maybe not, but it's a possible thing. Let's ask ChatGPT what kind of minerals were found on Mercury.
So, yeah, what's Mercury made out of? What
is the planet Mercury made out of?
I was max comfort zone. Now I'm in typing mode. What is the planet Mercury made of?
I'd say it has all the materials necessary to make these satellites.
Alright, so Mercury, the closest planet to the Sun, has a unique composition and structure. Iron core. Mercury has a large iron-rich core that makes up about 60% of the planet's mass. The core is believed to be partially liquid, which contributes to the planet's magnetic field. The core is composed primarily of iron, with some sulfur and nickel, giving Mercury a dense and metallic core. The mantle. But let's look at the crust, because ideally we're likely going to the crust, right?
Well, we're talking about deconstructing the planet little by little.
Well, we don't want. I really think there might be a danger in like completely taking the entire planet Mercury apart and using it, you know, like I feel like that would unbalance the way our solar system operates, and it might cause issues with a lot of the way everything works. You know what I mean?
Yeah, it
So
could,
if we
but I
use
mean,
some,
we took a lot of water here on Earth and put it in places that it wasn't before. And the rotation of our planet was in fact affected, but life is still here.
what I mean is, if Mercury gets to a point where there's no Mercury planet left, that might be a problem. If it ceases to exist. Because the thing about magnetic fields is there's a draw of attraction, right? But there's also a push. You know how if you get a magnet and you get the opposite, you know, and you can't put them together, they resist each other.
Right.
I think this magnetic influence that our planets have help keep our planets safely distanced away from each other.
Right.
Right? So if we take away one planet altogether, it's going to leave room. There's a gap now in that magnetic push-pull, right? So then our planet is going to move closer, because the closest planet to the sun is now gone, so which would take the second planet, and we're the third, right? So now we would be the second planet, but that second planet would be where Mercury is, because that magnetic resistance would be gone.
What if the energy...
I could be wrong.
What if the energy that we collected from the sun could be used to keep all the planets in check?
Well, you'd have to create such a artificial magnetic field in place of Mercury.
I mean,
right?
It could work.
I mean,
it could work.
I don't think we need all of Mercury's resources that bad to completely annihilate it.
Maybe we won't. But the mass would significantly change. But also, did you know that Mercury is smaller than the moon? It's actually smaller than Pluto.
We had some technical issues. It must have been the internet.
Uh-oh.
It's all right.
Did you know that Mercury is smaller than the moon?
I'm just seeing if the stream is up still.
It's still live.
Yeah, it's still up. Okay, good. Yeah, it's still live. That's a good thing. So, yeah.
Mercury is smaller than the moon, though.
Really,
I'm not sure if Mercury would have
smaller than our moon?
Yeah, it's even smaller than Pluto.
Let's see. Mercury is smaller than our moon. I feel like we need images of our as it's here. Planet comparison. All right, images. I don't know whose. Let's use this one maybe. All right, so we're just going to switch, I think. Share screen, and this one is this one right here. All right, so let's take a look at these planet sizes. So Mercury takes 59 days to make a rotation, but only 88 days to circle the sun. If we look over here, we've got the sun, Mercury, Venus, Earth, Mars. Oh wow, Mars is quite small, isn't it? I've never cared enough apparently to take notice, but I thought it was almost as big as Jupiter. And look, Pluto is right there, but I don't know. It was quite a bit smaller than Mercury, I believe. If this is accurate. Right, because this little thing is Mercury, or is Pluto.
Maybe I was wrong. I thought Mercury was smaller than Pluto. But in order for Mercury to have that much effect on the solar system, it would have to be a lot bigger. And would have to have a lot more mass.
I don't know. I really don't know. Like, I don't know if this drawing is the equal, like, if this is an accurate distance between the planets.
No, it's not.
Because in my theory, if it was a magnetic resistance that keeps us separated equally, it would be equal, essentially. You would think, right?
Right.
Like, it'd be like... But then again, the distance and the maybe it wouldn't be equal. Someone's cooking and they let the smoke detector go. At least I really hope that's what's going on. I hope my place is not on fire. I'm gonna have to go check. Otherwise I might die on this stream. Okay. Okay, we're good.
I think we're going to have a little bit of a recess.
All right. I'm back.
All right, everything's good?
Yep. Oh, wait, just 1 second. I'm good. I'm doing a podcast right now. Yeah, okay. I just got offered some chicken strip sandwiches.
Oh, nice.
Yeah, but I'm okay. I don't need some of those. All right. Even though chicken strip sandwiches are pretty good.
Oh, yeah, they are.
So, all right. It's quite an educational day today for me.
Yeah. It's educational for me as well. Today.
Alright, well, let's start sharing the ChatGPT stream. ChatGPT tab, where'd it go? There it is.
I did not.
Okay.
I was going to.
Oh, I've hit my limit apparently. I did not hit my limit. Yeah, I did actually. So let's discuss that railgun idea.
Yeah.
Because the idea of the railgun itself, it poses interesting um, solution, potential solution, but there's also some dangers to it.
Yeah, I mean, we're talking about making an object go at such a speed that it almost resembles the impact of an asteroid.
One thing I didn't know about Mars that I just found out right now is that Mars is home to Olympus Mons, which is the largest volcano in the solar system.
Oh, yeah.
So what would happen if the impact of our railgun woke that giant up?
I mean, maybe that's exactly what we need. I mean, if that giant woke up, it would cause a lot of seismic activity. It would cause. I mean, the idea here is that we want to make Mars habitable, like Earth is habitable for life here on Earth, to
But
be
if
on
that-
Mars.
But if that
And-
volcano erupted, wouldn't it cover the atmosphere in this this ash and cause like a sort of like a nuclear winter? But
I mean, our Earth has gone through a couple of different impacts in its lifetime, similar to what we're talking about, and it has gone through a couple of winters, like we're talking about, and life is still here, and it's thriving. And like I said, maybe that's exactly what we need for life to exist as it is on Mars here on Earth.
okay. But wouldn't it set it back? Like if the volcano became active and then like it would set it back. It also cooled the planet even more because the sun through that cloud, because I'm just going by what they say, you know what I mean, on about what would happen to our planet, and it would cool down, and yeah, it's.
I mean, these are all theoretical things, and I don't really know the answers to all these things, but
No, well, this is how we're going to explore saving the universe. And exactly what does the universe need saving from?
Well,
Us, maybe?
I don't know. That's a very good question.
I mean, there's a lot of people out there that like to theorize, I guess they call it, on how big the universe is and all this stuff. And I really don't think, like, they're throwing numbers out there and they're saying what shape is the universe and all this stuff. And I'm just like thinking to myself, like, I really don't think that we comprehend it at all. To be fair, like, they're trying to measure things in a way that's tangible to their logic, but the universe is so far beyond our human understanding of everything, you know. And for a long time, people just thought that the Milky Way was the universe, and that was it, right? Until they learn more. And now they're learning more and they think this is it, you know, that is it, right? But I think it's just so far beyond and in a much bigger scale. Like, it's infinite, dude. I think
I
there's
mean,
no shape. I really don't think there's a shape to it.
well,
Because if
I
there's a
think that
shape
the
to it,
universe
then
is
there's
more
have to
like a
be an end to
balloon.
it. And if there's an end to it, what's beyond that? Like, what's beyond the edge of the universe? What's beyond? What if it has a shape that they're trying to say the universe is a certain shape? Then, like, how is that even possible to have a shape? Because it would
Well,
then
it's got to have a
infer that
shape
there's an end.
it's got to have a shape when it started, right? At least a fine point in which, I mean, the scientists say that when the
And if it
universe
has
was
an end, what's
created, it was very small. It was almost like a pinhead. And as it grew, it was very hot in the beginning. And then, the universe was made out of stuff like quarks and different things. And
I think they got it all wrong, to be fair. I really do. I think they got it all wrong.
you
Like,
think?
there's no way that they can understand. Yeah, of course I do. There's no way. There's no way.
I mean, Einstein had it right when he thought he was wrong. I mean, he didn't think that black holes existed, even though he proved that they existed. And now we're taking pictures of the thing he didn't think existed. So his biggest screw up was that he thought he screwed up. You know what I mean?
Well, there was also another thing that he got wrong, and then another person, he went to go look at through the Hubble space scope because he thought everything was static in space. He didn't think anything moved in space. He thought it was just all in one spot. Like, he didn't think there was like rotational or like, you know what I mean? And then he got to look through the Hubble space scope, or the Hubble telescope, or the guy. There's a telescope that Hubble had that he invited Einstein to look through, and then as soon as Einstein looked through it, he's like, "Wow, that's probably one of the biggest mistakes of my life was saying this." And now, I think we should look it up actually. Just so there's some factual this to it, maybe. Let's see where.
Yeah.
I don't know where I put my I didn't close ChatGPT screen. It's there. Where's the view tab? Can I view the tab? View tab. Oh, here it is. Perfect. Thank you, Streamlabs. By the way, we are using StreamYard, not Streamlabs. We're using StreamYard.com. And if you want to start a podcast or do a podcast or stream anything without even having to download software, and then have someone come on the stream with you, StreamYard's very user-friendly. I've used different streaming products over the years, and really I find for this particular instance where I've got another colleague beside me in a different country. I'm from Canada and Broadband's from America.
Merca.
And we're able to we're able to go together and do this and have a conversation. It's just it's great. And StreamYards has been able to make that happen. So if anybody watching this wants to try, go to StreamYards.com and just play around with it. And it's super easy. and user-friendly. Anybody could do it. Anybody could do it. Even Mercury. Mercury could do it if they wanted, but they're little. Anyway, so the question proposed to we're gonna just start a new chat here. So the question proposed was, what was Einstein wrong about before he looked through the telescope? It'll know. Alright, so it says, before Albert Einstein looked through a telescope, he wasn't necessarily wrong in a conventional sense, but there was several key areas in physics where his understanding was incomplete, or where his theories were later refined by subsequent discoveries. One of the most significant moments related to Einstein's theories and observational evidence came with the prediction of the bending of light around massive objects. In his general theory of relativity, Einstein predicted that light would bend when passing near a massive object due to the curvature of space-time. The prediction was famously confirmed during a solar eclipse in 1919 by Sir Arthur Eddington, who observed the apparent position of stars near the sun shifting due to the sun's gravitational field. Prior to this, Einstein's theory was still largely theoretical and was the observational evidence seen through telescopes during the eclipse. That confirmed his predictions and led to broader acceptance of his theory of relativity. Before this, Einstein's work on relativity was largely based on theoretical calculations and lacked direct observational validation. I'm talking more about, I'm talking more about his experience with Hubble. Albert Einstein's direct interaction with Edwin Hubble involved a key moment in the history of cosmology. Einstein had initially embraced the idea of a static universe, which was the prevailing view before Hubble's observations. To account for the fact that the universe was not collapsing under its own gravity, Einstein introduced a cosmological constraint, or constant, into his equations of general relativity. This constant was intended to allow for a static universe by counteracting gravitational collapse. However, Edwin Hubble's observation in the late 1920s showed that the universe is actually expanding. Hubble discovered that distant galaxies are moving away from us, with their speed proportional to their distance, a relationship now known as Hubble's law. This finding implied that the universe was not static but expanding, which was a significant blow to the static universe model that Einstein had supported. Einstein famously referred to his introduction of the cosmological constant as his biggest blunder. Once he recognized that the universe's expansion rendered the need for his constant obsolete, he later embraced the implications of Hubble's work and the expanding universe model, which eventually led to the development of modern cosmology, including the Big Bang Theory. So, Einstein's error was his initial belief in a static universe, which was corrected by observational evidence from Hubble. So, that is... Oh, where'd Mike go?
I'm here.
Okay. You lost your picture, buddy.
I lost my what?
Your picture.
Oh no. It says it shows my pictures on my guy.
Okay. Well, that's all right. But you heard what
Yeah.
ChatGPT said. So
Yeah, he believed in a static universe.
Yeah.
And that was proven wrong by the Hubble Space Telescope.
Right. So I really believe that we're just gonna keep finding more things, new things, all the time. Where our current belief system is going to be challenged by future revelations.
Right.
Right? It's just we still can't comprehend. Like, we can only see what we can see.
I mean,
But
honestly,
we don't know, though, right? Like, we
I mean,
really don't.
we don't know until we do know. And I think it's well beyond our time when we do end up knowing or not knowing. Maybe we won't ever know.
So
But I
during
do
our
have
conversation with ChatGPT earlier, though, we were posed with some problems about reigniting the core of Mars that you had found out, Mike.
yeah.
So do you want to explain some of that, maybe?
So, the Martian magnetic field is pretty much non-existent, considering the core is pretty much solid and not liquid. There's no convection currents going on to make a magnetic field strong enough to produce an atmosphere capable of protecting the
Keeping-
surface from harmful rays coming from the
Right.
sun. So we would have to create convection currents capable of maintaining a magnetic field capable of maintaining an atmosphere on Mars. And that's one of the first problems.
Yeah, there was one of the issues, though, that kind of bothers me a little bit, and I don't agree with what Chat said, but it was about the size of the core. Do you remember what it said about the size of the core?
Let's see. Can you still hear me?
Yep.
All right. So, according to my chat with ChatGPT, can you still hear me?
Oh, of course.
All right. So, igniting the core of Mars to create a stronger magnetic field would be an incredibly complex and challenging task, with numerous technical, physical, and environmental problems. Here are some key issues that would arise. Insufficient core material. Mars has a smaller core compared to Earth, and it is likely less dense and contains less iron. The core might not have enough material to sustain the kind of vigorous convection currents required to generate a strong magnetic field. The Martian core is believed to be partially or fully solidified. Igniting or remelting it would require an immense amount of energy. Even if this energy could be applied, the resulting state might not support the necessary convection currents due to differences in composition compared to Earth's core. The energy required to alter the state of Mars's core would be astronomical. It would likely exceed any practical or conceivable energy source available to humanity, making it extremely challenging to implement. Attempting to heat the core could cause significant geological instability. This could trigger massive seismic activity, volcanic eruptions, or other planet-wide disruptions, potentially making Mars even less hospitable than it currently is. The technology needed to penetrate deep into the Martian mantle and deliver energy to the core does not exist, or so ChatGPT says. Developing such technology would require unprecedented advances in multiple fields, including materials, science, engineering, and energy generation. Even if the core could be ignited, the process could drastically alter Mars's environment in unpredictable ways. For example, it could lead to the release of gases trapped within the planet's interior, potentially altering the thin Martian atmosphere in ways that could be harmful to any existing or future life forms. The dynamics of planetary cores and magnetic fields are not fully understood. Even if the core could be ignited, it is unclear whether this would indeed result in a sustained and strong magnetic field. And there is a risk. Excuse me. There is a risk that the outcome could be ineffective or even detrimental. International agreements like the Outer Space Treaty emphasize the protection of other planets from contamination and significant alteration. Igniting Mars's core could violate these principles, leading to international disputes or restrictions.
Whoa. Say that again, that last part?
Let's see. International agreements like the Outer Space Treaty emphasize the protection of other planets from contamination and significant alteration. Igniting Mars's core could violate these principles, leading to international disputes or restrictions.
Okay, alright. So what is the name of that treaty again?
The international, let's see, excuse me. It's called the Outer Space Treaty.
Alright, let's see what the Outer Space Treaty is, because I've never heard of that. So the Outer Space Treaty, formerly known as the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space. Okay, that's a really bold set of rules that already, like, I'm feeling like how, like, I haven't even begun to read it, and right away I just feel like huge overstepping. But including the moon and other celestial bodies is a landmark international agreement that was opened for signature on January 27th, 1967, and entered into force on October 10th, 1967. It is often referred to as the cornerstone of international space law. So here's some key points of the treaty. Peaceful purpose. Outer space, including the moon and other celestial bodies, shall be free for exploration and use by all states, and activities there should be conducted for peaceful purposes. Weapons of mass destruction are expressly prohibited in outer space. Okay, so free for exploration and use by all states. What about the people? Right? That's one question. Like, for use by all states, but what about people? Regular people. You know, like the space cowboy.
Like Elon Musk.
Well, he's got a pass, clearly. Non-appropriation. No nation can claim sovereignty over outer space or any celestial body. The treaty prohibits any nation from claiming ownership of the moon or other celestial bodies by occupation, use, or other means. So, those people selling stars are violating that, aren't they?
Sounds like it.
Well, a star is a celestial body, and some people are selling stars. Right? You own this star. Anyway, international cooperation. States are encouraged to cooperate in the exploration and use of outer space and to share information and findings. The treaty emphasizes the importance of international cooperation in the peaceful use and exploration of space. Okay, well, after reading 3, I'm kind of toning back on the overstepping, because I feel like, you know, it's pretty reasonable what they've been talking about. Responsibility and liability. States are responsible for national space activities, whether conducted by governmental or non-governmental entities, and are liable for any damage caused by their space activities to other states or their space objects. So, states are responsible for national space activities, whether conducted by governmental or non-governmental entities. Okay, states. Not every country has a state, though. Like, I live in Canada, we don't have states.
Well, technically, a country is considered a state,
Okay.
and you know, based on like my education in high school, technically a country is a state.
All right. I'll accept that. Freedom of exploration. All states have the freedom to explore outer space and conduct scientific investigations, provided they do so in accordance with international law and respect the rights and interests of other states. The treaty has been signed and ratified by over 100 countries and forms the basis for subsequent space treaties and agreements, such as the Rescue Agreement, the Liability Convention, the Registration Convention, and the Moon Agreement. Its principles are crucial in ensuring that space remains a domain for peaceful exploration and cooperation, rather than conflict or territorial claims. Okay, all right. I can get down with most of that. I don't know if they'd let just me or you build a spaceship and let us go fly off in outer space or not, but
I mean, Elon Musk isn't technically a government person or anything like that. He's not part of NASA, and he sent rockets into space. I mean, he's got
True.
multiple satellites orbiting the Earth. So
he's also been tasked to go rescue the two astronauts that are in the space station currently, where the Boeing, I think it was Boeing, Boeing had made a spaceship or something, and there was a malfunction in the spaceship, and they've kind of been trapped in the I just said the word. Come on. In space station. They've been trapped in the space station without a way back home. So Elon Musk is using SpaceX. He's been approved to be the one to go get them. Not him personally, but SpaceX, right?
yeah, his technology is going to be used to go to the space station and basically go get the astronauts.
I mean, the way that SpaceX has come forward and the innovations that they've done for space travel alone, it's exciting, I think, and it's quite remarkable. There's some big things happening over in that corner, and I just feel like he doesn't, like, yeah, he may be arrogant, he may be a jerk, and people are probably envious of his success, but he's done a lot, man. He's done a lot, and I really think that if anybody could, now also to go back to what you were saying about what ChatGPT said about how it could violate something in the space treaty, right? In the outer space treaty. I didn't see anything in there that would violate that in regards to trying to reignite Mars's core. Did you?
No, I think that it's a very peaceful endeavor to try and
Right.
reignite the core and to make the atmosphere necessary to support life.
I don't think we get the pass to use a nuclear weapon now, though, to reignite the core, because it says weapons of mass destruction are expressly prohibited in outer space.
So we would have to use other means.
Yeah, I don't think they'd let us use a big railgun either, would they?
No.
Because
or
that,
maybe,
in turn, well,
maybe, I mean, a railgun could be used for non-destructive purposes.
Yeah, but what if somebody wanted to go and capture it and then hold the world hostage by redirecting that railgun at certain areas of the Earth?
Oh,
Right?
that might be up for discussion.
I mean, that's probably a new man. We just made a movie idea. You know, seriously, people build a railgun to reignite Mars's core, and then it gets hijacked, right? And then, thankfully, Steven Seagal is a cook on that railgun, and he fights off the terrorists that are trying to hijack the railgun, right, and saves the day.
Wouldn't that be a trip to watch?
I mean, that's a good movie, and thankfully we've got it on stream. So if anybody wants to take that idea, Steven Seagal, if you're interested, I did see a lot of his movies. It just reminded me of that movie where he was on the military ship, and I can't remember the name of that movie.
Let's ask ChatGPT.
Let's ask ChatGPT. Yeah, 100%. What was the Steven Seagal movie where he was a cook on a boat? Under Siege. Ah, come on. I should have known that. I knew it started with a U. I've seen like every Steven Seagal movie. I grew up in the 80s, so yeah. The Steven Seagal movie you're thinking of is Under Siege, 1992. In this action film, Steven Seagal plays Casey Ryback, a former Navy SEAL who is now working as a cook on the USS Missouri, a battleship. The plot revolves around a group of terrorists who hijack the ship, and Ryback uses his military skills to thwart their plans and save the day. The movie was well received for its action sequences and Seagal's performance, and it remains one of his most popular films. I mean, it was a good movie. I'm not gonna lie, it was a good movie. And we could just basically take Under Siege, right, and then adapt it to our Railgun theme, and add the, it's not done. It's not done. All these writers are doing reboots of like all these movies that came out in the 80s and 90s and early 2000s because they can't write new things. They're just like, oh, let's just take this cool movie and remake it so we can just kind of like milk this market even more, and we don't have to do much. We just got to tweak some things and put in some new actors, and there it's done. We write a new concept. That's a little bit more time, but look, we just did that in 10 minutes. We created a unique movie about space, terraforming Mars, getting Steven Seagal back in the movies, and saving Earth all at the same time.
Wow.
Speaking of saving Earth, though, we did, through our conversation today, figure a way to get the greenhouse gases and stuff that's causing, how Earth has a climate change disaster we're kind of dealing with, right? And what did we figure out to do with that, Mike?
So, repeat that again, just so that I can comprehend it.
How were we planning on saving Earth from this global warming crisis?
So we were talking about taking some of the greenhouse gases and stuff that are trapped in our atmosphere and putting those greenhouse gases on Mars to try and create the greenhouse effect on Mars while saving our planet by taking those greenhouse gases away.
Right. So essentially, we capture greenhouse gases with devices here on Earth, and then transport that captured greenhouse gases, transport those to Mars, and then release it into Mars so we can thicken up Mars's atmosphere. Right? And this essentially is how we got on this topic, to be fair, because one thing led to another, right? So I had proposed a conversation to you that I was having with ChatGPT about this procedure about transferring gases, and then Mike's beautiful mind was like, yo, great idea, but it wouldn't be able to keep the atmosphere. And I was like, what do you mean? And he's like, well, because of
the magnetic field that doesn't exist on Mars.
right. So now here we are trying to figure out how to reignite Mars's core so the magnetic field can keep the greenhouse gases that we're going to transfer from Earth to Mars.
Yeah, and there's also another thing. There was something I was reading the other day about how we could potentially cool the Earth down by putting some type of gas in our atmosphere that kind of blocks some of the solar rays from entering the Earth's atmosphere, and it could cool the Earth down significantly and cause our Earth to, not have that runaway greenhouse effect. But there are some things that I think could be detrimental, like it could change the currents in the ocean. It could change the weather patterns. It could change everything. But the thing is, well, the runaway greenhouse effect is already happening and has been happening, and the currents are changing already. We might want to think about what's already happening versus what could happen, because the currents in the ocean are changing because the atmosphere is getting hotter. Everything's changing because of how the Earth is heating up, and if we cool it down, maybe everything will change for the better. We don't want things to stay stagnant. We want it to change, because things are always changing. And
well, yes, things are always changing for sure. But the currents you were talking about, it's definitely happening, and it's causing more harsher weather in different areas, right?
Especially here in Arizona, we've had 2 tornadoes in southern Arizona in the last couple of months, and that's something that's unheard of. I mean, like here, especially in southern Arizona. I mean, you can look this up. There were 2 tornadoes here in southern Arizona. One of which caused a little bit of damage, and the other one didn't really damage anything at all. But it's just crazy that there's even tornadoes happening here in the desert, because one, tornadoes happen when a high pressure meets a low pressure.
Yeah.
And, a dry, arid meets, wet, what do they call it? A wet,
like humid
area. You know what I mean?
Well, wind alone is caused by warm and cold coming together, right? And
atmospheric pressure.
And how fast everything cools down, right?
Yeah. And when those two things mix, it causes tornadoes.
And when you've got a body of water that's not normally a certain temperature, and it's in a certain area, it's gonna change the air above it because heat rises, right?
Yeah. It causes a current. And that in turn causes tornadoes. And it's
So-
the same thing. It's the same thing with hurricanes too.
And Mars has a lot of this kind of activity.
Yeah, and so does Jupiter and Neptune
But what do you
and
think? There's no water on the surface of Mars right now, right?
as we
So-
know of,
Well, we haven't seen any water on the surface.
underneath the surface though.
Right. But what do you think is causing that cooling off and heating up that's creating the wind that Mars has the storms with?
It might have a lot to do with the solar rays, other things. I'm not really sure.
Because if the core isn't really active, there wouldn't be much heat coming from geothermal, from the ground, right?
Right.
So where is all this weather action coming from?
Let's ask ChatGPT.
That's a good question. Okay. Sorry, I was eating wings. Where does all the harsh weather come from on Mars if it's so cold? Let's say. So Mars, despite its cold temperatures, experience various types of harsh weather. Here's where some of it comes from. Dust storms. So Mars is known for its planet-wide dust storms, which can cover the entire surface of the planet. These storms are driven by the solar heating, you were right, and the resulting atmospheric pressure changes. Even though Mars is cold, the storms are significant because of the planet's thin atmosphere, which allows dust to remain suspended for long periods. Okay, alright. So, seasonal changes. Mars has seasons like Earth. That's cool. Due to its axial tilt, it's about 25 degrees, which is similar to Earth's 23.5 degrees. Seasonal changes cause variations in temperature and atmospheric pressure, contributing to weather patterns. For example, during the Martian winter, CO2 can freeze out of the atmosphere and accumulate at the poles, causing changes in atmospheric pressure and contributing to seasonal weather changes. They've got polar ice caps. Mars has polar ice caps composed of water ice and frozen CO2. Well, if it's composed of water ice, then we know it has got water on it. During the winter, the polar ice caps expand as CO2 freezes out of the atmosphere. In the spring, the ice sublimates back into the atmosphere, contributing to atmospheric pressure changes and influencing weather patterns. I mean, that's cool. Temperature variations. Despite its overall cold temperatures, there are temperature variations between day and night and between different regions of Mars. These variations can create wind patterns and contribute to weather phenomena. The thin atmosphere means there is less insulation, so temperatures can swing dramatically between day and night. And topography. Mars has varied topography, including mountains, valleys, and impact craters. These features can influence local wind patterns and weather conditions. For example, wind patterns around large volcanoes like Olympus Mons can create localized weather effects. Even though Mars is generally cold, these factors contribute to its dynamic and sometimes harsh weather conditions. Well, that's pretty cool. So water isn't the only effector.
Absolutely.
So we've got, we've got the a solution for the atmosphere, and we've got a solution for the silica that you created today, right?
Yeah,
We've got some.
the algae that eats silica.
Mm-hmm. Now,
What were those called?
That's a good question. Let's see. No. All right. Okay, it was diatoms.
Diatoms.
Let's see what a diatom looks like. All right. Let's see this. Oops. Okay, go.
Oh, wow.
So these are the algae that will eat silica.
That's crazy. Show that bigger if you can. Like, is there a way to do the StreamYard thing where it...
Oh,
where
maybe I can do this full screen here. Can you see it better now?
Yeah. Holy crap, those are cool looking.
So we've got those. That's one thing. But then I seen that there's a moss, actually, that can survive on Mars. That we've got recently. I'd like to show that too. So I'll do right there. So it says scientists in China say they have discovered that a type of moss would survive on Mars. It's Centrichia canaveris. Centrichia canaveris is a type of moss usually found in regions such as Antarctica or the Mojave Desert. But now scientists have been found that it can survive Mars-like conditions, including drought, high levels of radiation, and extreme cold. So I'll show you what this sucker looks like. New tab. Here we go. It's probably about $35 a gram.
Wow.
So that's the kind of moss that we could put on Mars.
What does it do, though?
Well, I'm glad you asked, because we're going to ask ChatGPT. So, I'm going to copy that, and then we're going to go back to ChatGPT. Using to share screen. So the appearance of it is a small, tuffy moss that typically forms dense mats or cushions. The plants are generally low-growing and can vary in weight. The leaves are often narrow and lance-shaped, with a distinctive nerve running through the center. They are usually green, but can sometimes appear yellowish or reddish. Let's see. Its ecological role. That's what you're interested in. So, colonization. Centrica cnivarus is known for its ability to colonize harsh environments. Its resilience makes it a pioneer species that can establish itself in areas with poor soil and limited moisture. Soil formation. As a pioneer species, it contributes to soil formation and stabilization by helping to create a more hospitable environment for other plants. Spore
I like that.
reproduction. Like other mosses, Centricia cnivarus reproduces through spores, which are released from capsules produced by the moss. The spores are dispersed by wind and can germinate in suitable conditions. So, yeah. So we've got the moss, we've got the algae, we've got greenhouse gases that... So we just really need to get... that core going.
Yeah.
Really, we really do. But what about the air quality? Like, there's radiation that says on Mars, right?
Well, that could be from the solar rays.
Yes. Yeah, well, it would have to be. Where else would it come from?
I would
Right.
presume that we put something in the atmosphere that basically allows the atmosphere to kind of block some of those rays, and
Huh.
that way some of the radiation that could be on Mars would no longer affect Mars.
So really, we just need to... Well, let's, sorry. I'm just munching away. I'd love to do that hot wing challenge on that YouTube channel sometime.
Oh, you're talking about the hot ones?
Yeah, that's it. I like that show. I like talking to people for a purpose, you know?
Oh yeah.
So let's exit the full screen layout. Back to our beautiful faces. Look at us. We're just a couple circles with pulsating backgrounds. You know. Anyway, so we were going to ask about the air quality on Mars, right?
Yeah.
On Mars, and how to deal with the radiation and increase good oxygen so humans can breathe. Alright, so improving air quality on Mars for human habitation involves addressing several challenges, including the planet's thin atmosphere. Well, we've already covered that part. High levels of radiation and the need for breathable oxygen. Here's a comprehensive overview of the issues and potential solutions. The air quality on Mars, the current atmospheric conditions, the thin atmosphere. We've realized that. Mars has a very thin atmosphere, about 1% as dense as Earth's. It consists mainly of carbon dioxide, about 95%, with only a trace amounts of oxygen, about 0.13%. Lack of oxygen. The atmosphere is not breathable for humans as it lacks sufficient oxygen needed for respiration. High radiation levels. Mars lacks a strong magnetic field and thick atmosphere, leading to high levels of cosmic and solar radiation on the surface. This radiation poses health risks to humans and can damage habitats and equipment. So, increasing oxygen levels. So there's a thing called MOXIE technology. The Mars Oxygen in Situ Resource Utilization Experiment on the Perseverance rover is designed to convert carbon dioxide from the Martian atmosphere into oxygen. Scaling up this technology could provide a continuous supply of oxygen for habitats. Electrolysis of water. If water is extracted from Mars, ice, or produced from hydrogen and oxygen, electrolysis can be used to split water into oxygen and hydrogen. The oxygen can be used for breathing, while hydrogen could be used as fuel combined with carbon dioxide to produce methane. Algae and plants. Look, we're already there. Look, you've come with the algae. The moss is a plant, right?
Yeah.
So growing algae or plants in controlled environments could produce oxygen through photosynthesis. Systems such as bioregenerative life support systems could integrate algae, plants, and other organisms to create a sustainable oxygen supply. Okay, so we're getting really close, okay? Like super close. Super close. It would take some time though, right?
Yeah.
But there's an article out there that says that they could terraform Mars in a few months. No, there's an article out here. Alright, okay. So, when was this created? Okay, this might be it.
Pardon me.
Oh, you're good. You're good. Alright, we're just gonna go full screen on this so everybody can see. Alright, so what was this ad for? Come on. I don't want that thing right now. Alright, so revolutionary approach to terraforming Mars could warm planet in months. Only now is it becoming apparent that this science fiction dream of terraforming Mars yesteryears is close at hand. New studies suggest that added to Mars' atmosphere, just a few specks of particles would heat it by over 10 degrees Celsius in months, potentially making it hospitable for liquid water. What? Just a few specks of particles. Can you imagine?
Yeah, that sounds crazy.
Well, we'll see what they got to say. It relies on resources easily procurable from Mars. The idea is to manufacture small rod-like particles using Martian dust, material rich in a lot of iron and aluminum. Such artificial particles would trap the escaping heat from the sun and scatter some of the light back to the surface, therefore boosting the weak greenhouse effect of the planet. This would warm the planet to an extent far greater than previous proposals that would require shipping gases from Earth or mining Mars for its rare minerals. Whoa, okay. So other people clearly have just thought about shipping gases from Earth to Mars. That's clearly not revolutionary then. Dang. But guess what? Those smart
We don't
people,
need to, apparently.
but those smart people that spent all that time thinking about it, these smart people were thinking about it too.
Yeah.
And guess what? They got degrees in school and all that stuff, and we're just two dudes, right? That clearly are just brilliant.
Two brilliant dudes.
Right? But we're like the dangerous kind of brilliant that's untrained. And if we applied that training, clearly we'd be railgunning Mars.
Oh. Yes.
All right. So it's not that often you get some quite new, innovative idea for terraforming, said Colin McHines, a space engineer at the University of Glasgow who was not involved in the study. As he points out, the gap between Mars' current state and its habitability may be much less of a chasm than we usually envisioned. Well, of course, nothing is impossible. This research group from the University of Chicago and the University of Central Florida created particles approximately the size of commercially available glitter that can trap heat much better than the dust on Mars. These engineered nanoparticles in very small amounts could bring with them optical effects that are outside any conventional expectations. You would still need millions of tons to warm the planet, but that's 5,000 times less than you would need with previous proposals to globally warm Mars, says Kite, another co-author. Calculations suggest that pumping these particles continuously at 30 liters per second could warm Mars by as much as more than 50 degrees Fahrenheit with discernible effects within months. The warming would also be reversible, stopping within a few years if the particle release was stopped. Still, the researchers caution that much work remains. It's still not clear how quickly the engineered dust would cycle out of Mars' atmosphere as the planet heats up. Water could begin to condense on the particles, dropping back to the surface as rain, another layer in the already complex climate. Climate feedbacks are hard to model. Kite says much more data would be required, both from Mars and from Earth, if impacts were to work as expected, and any actual implementation would need to proceed slowly and reversibly. While this method represents a huge step forward in research on turning the desert planet into a potential abode as the Earth's sister, the study concerns warming Mars to temperatures at which microbial life could survive and maybe even sustain the raising of food crops. This research opens new avenues for exploration and potentially brings us one step closer to the long-held dream of establishing a sustainable human presence on Mars. Well, it's interesting, and I didn't know Mexico. I didn't know Mexico was going through a drought right now. And here we are trying to save Mars.
Yeah.
I mean, we're part of the universe. Earth is part of the universe. So learning how to save the universe would be learning how to save Earth as well, right?
Yeah.
Because if we don't save Earth, then, well, we're fudged. so to speak.
Yeah.
This
I've
article is
always
kind of.
been
Oh, sorry. Go ahead.
I've always been a big advocate for building a Dyson swarm around the sun so that we can collect the energy from the sun so that we can save the earth. Because, they say we're going through an energy crisis. And I believe that that could be curbed by harnessing the raw energy of the sun. And
I just totally disconnected myself from this stream real quick. I didn't know what I did. I hit a button on my mouse and then I was gone. But I'm glad you're still here and it's still live.
yeah,
Sorry, guys.
it's all good. But I was just saying that, we have an energy crisis supposedly here on Earth, and if we built the Dyson swarm, we would save the Earth, because we would curb any need for energy. I mean, I watched a video by Kurzgesagt, and they showed basically how astronomical the amount of energy we would be receiving from harnessing the raw energy of the sun. I mean, we're talking about a giant. I mean, the Earth is like a pinhead compared to like a basketball, and
Right.
the basketball being the sun and the pinhead being the Earth.
And the size of Jupiter. Oh my.
And just we're trying to harness the raw energy of the sun. I mean, that would be astronomically, just so much energy that we wouldn't even know what to do with it. And
let's
that
take a look
way,
at this article. You see this article right here where it says black hole in a planet's orbit could indicate an advanced civilization.
oh really?
Well, that's what the article says. And the story is by Nicole McFadden. I don't know. Faith Zodiac. I don't know what that is, but that's some credit to the author of this article. So black hole. Oh, go back. So the black hole in a planet's orbit could indicate an advanced civilization. An English mathematical physicist and Nobel Prize winner named Roger Penrose hypothesized how energy could be extracted from a rotating black hole in 1971. He proposed constructing a harness around the black hole's accretion
disk,
where infalling matter reaches near light speeds, which would trigger an enormous release of energy across multiple wavelengths. Wow, okay, so this is really close to what we were discussing earlier in the beginning of the stream, right?
Yeah, when we were talking about shooting electromagnetic energy into a spinning black hole.
So since then, several scientists have proposed that advanced civilizations might use this idea, dubbed the Penrose process, to power their technology. This technological possibility suggests just one interesting technosignature that scientists looking for life beyond Earth could search for in outer space. So next part of the slide. Following hypotheses. Building upon this idea, scientist John M. Smart has proposed the transcension hypothesis. In this hypothesis, he suggests that advanced intelligence may migrate to regions surrounding black holes. There, they could take advantage of the energy available. The latest idea, based on the Penrose process, comes from Harvard professor Avi Loeb. His paper, where he poses his latest findings and ideas, illumination of a planet by a black hole moon as a technological signature, was recently published in the scientific journal Research Notes of the AAS. Avi Loeb's paper. Professor Avi Loeb is an extremely accomplished scientist. He is the Frank B. Baird Jr. Professor of Science at Harvard University, the director of the director of the Institute for Theory and Computation at the Harvard Smithsonian Center of Astrophysics, the founding director of the Black Hole Initiative, and the head of the Galileo Project. What's the Black Hole Initiative? In the latest paper, he proposed the advanced civilizations could rely on black hole moon to provide their home planet with power indefinitely. He argues that the way a black hole would light up the planet it orbits could serve as a potential techno-signature for future SETI surveys. SETI stands for Search for Extraterrestrial Intelligence. Stephen Hawking's theory. In 1975, Stephen Hawking theorized that black holes emit photons, neutrinos, and some larger particles. These theoretical larger particles have been called Hawking radiation. Since then, proposals for harnessing black holes as an energy source typically fall into one of two categories. Some scientists believe in the possibility of the Penrose process, which involves capturing the energy from angular momentum of black hole accretion disks. Similarly, some believe that capturing the heat and energy generated by black hole hypervelocity jets would be possible, perhaps in the form of a Dyson sphere. On the other hand, some believe that these black hole civilizations would have to feed matter into the black hole they rely on and harness the resulting Hawking radiation in order to create power. That's like sacrificing, you know what I mean? Like, it's almost like a sacrifice.
Right. You're getting more out of what you're putting in.
But they're like kind of like sacrificing something to the black hole god, and it's giving you power.
Yeah.
So an orbiting black hole engine. In his recent paper, Loeb proposed that an advanced alien civilization could rely on the latter process by engineering a black hole to orbit their home planet. This black hole would be relatively very small, weighing just 100,000 tons. Yes, this sounds like a lot, but is not in terms of black holes. However, without any sort of maintenance, this black hole would evaporate in just a year and a half through the emission of Hawking radiation. Loeb explained that luckily for any potential civilization, a black hole could be sustained by giving it small amounts of matter, about 4.5 pounds per second. In return, 4.85 pounds per second. In return, the black hole would offer a continuous supply of power.
It's thoughtful.
It's powerful and efficient. The black hole system is the most efficient engine that I ever thought about, Loeb explained. The fuel is converted to energy with the perfect efficiency of 100% because the mass falling into the black hole is ultimately coming out as Hawking radiation. I've not seen this idea discussed before and had a eureka moment when I realized it a few weeks ago. According to Loeb, the amount of antimatter needed is currently beyond humanity's capabilities. A civilization more advanced than our own would have to figure that out. However, Loeb's proposed 10 to 11 gram black hole could continuously supply 40 quadrillion watts of power, which is certainly enough to power a planet. Well, I just thought about that reading the article. Using waste for energy. The global energy use is a few terawatts, 10,000 times less than the power supply of the black hole. Loeb explained another benefit is that the black hole can use any type of matter as fuel, including the waste generated by civilization. In this way, a black hole engine could address an advanced civilization's waste disposal issues while simultaneously offering a limitless source of energy. The other advantage of this black hole engine is that it can use any form of matter as fuel, Loeb said. It could be trash. There's no better way to recycle trash than convert it into clean energy with 100% efficiency. Well, we do that on our planet with our waste disposal centers, right? Like they create energy from our trash.
Yeah.
Right? So it's really a waste disposal center of the galaxy. Yeah. Yeah, let's see. A techno signature on Earth. This is the big challenge, Loeb said. Any production line of 10 to 11 gram black hole requires compressing matter of radiation to a mass density that is 60 orders of magnitude above the density of solid iron. The density of atomic nuclei or neutron stars is only 15 orders of magnitude above solid density. This was possible to achieve in the cosmic radiation density less than a femtosecond after the Big Bang. In another recently written paper by Loeb, he argued that, based on the theory of general relativity, black holes could be made out of light, according to his theories. This proposed black hole engine would be detectable light years away, which might be most interesting about his hypothesis. This would make black hole engines viable technosignatures that would indicate the existence of a faraway advanced civilization to scientists. So essentially what I think they're saying is, if they're looking at outer space, right, and they see a black hole close to a planet that's a certain size, I guess, it could be a possibility that it's been manufactured to sustain the planet's energy source. Is this what you think? I'm getting that right?
Yeah.
Yeah. That's interesting. So ooh, NASA and Boeing not having such a good time right now. Well, it doesn't surprise me, really. Really doesn't, for some reason. So it's really got me thinking. We could, like, I read an article not long ago that somebody made, like, simulated a black hole in a lab here on Earth, clearly, and but they simulated a black hole, and then with the Large Hadron Collider, they could make a black hole with that too. So if they put one in space and then gave it enough mass to create a black hole the size they need, they could get the power to boot up Mars's core again, right? Because in that theory that we were talking about earlier, it was saying, oh, there's not enough power, you couldn't fathom how much power you would need. Well, clearly we can fathom it now because we've got a black hole engine that we could harness now, right? So theoretically, with I think we can boot up Mars, guys. I really think we could boot up Mars.
Yeah.
How long does it take to travel to Mars?
I don't know. Couple of weeks, maybe a couple
let's
months.
see. Share screen. Let's go to share. How long does it take to travel to Mars? Okay, The time it takes to travel to Mars depends on several factors, including the relative positions of Earth and Mars, the spacecraft's speed, and the specific trajectory used. Here are some key points to consider. Orbital mechanic. Hohmann transfer orbit. The most energy-efficient trajectory for traveling to Mars is the Hohmann transfer orbit. This trajectory takes advantage of the positions of Earth and Mars to minimize fuel usage and travel time. It involves launching when Earth and Mars are in optimal alignment. Well, that makes sense. Average distance. Mars and Earth are about 54.6 million kilometers apart of their closest approach. At their farthest, they can be about 401 million kilometers. Wow. 245 million miles apart. I'd sooner travel to 54.6 million kilometers, or 33.9 million miles, other than 400 million miles. Historical missions. So NASA Mars missions, past missions, have taken between 6 to 9 months to reach Mars. Mars Pathfinder, about 6.5 months. Mars Science Laboratory, 8.5 months. And Mars Perseverance rover, 7 months. Optimized trajectory for future missions. Future missions could potentially reduce travel time using advanced propulsion technologies for different mission profiles. However, travel times will likely remain in the range of 6 to 9 months with current technology. So, propulsion technologies and travel time. Well, that's an interesting factor, right? Like, thinking of propulsion in outer space and how that works to get to these places. The current technology, we've got chemical propulsion. Have you ever heard of that?
Yeah, isn't that what we use in our conventional rockets?
I guess so, yeah. Most spacecraft use chemical propulsion systems, which provide the thrust needed for interplanetary travel. The method results in travel times about 6 to 9 months.
I think we should start using railguns for space travel.
You're all about railguns.
Oh yeah, you know I'm all about those railguns.
Advanced propulsion systems, the nuclear thermal propulsion, that sounds exciting, could potentially reduce travel times by providing more efficient thrust compared to chemical rockets. Electric propulsion, ions or plasma propulsion, could offer higher efficiency but generally result in longer travel times due to lower thrust. Proposed concepts, advanced concepts like fusion propulsion or laser sail technology, could theoretically shorten travel time significantly, but these technologies are still in development. So, it's not as long as I thought it was to go to Mars, to be fair. Like, that's pretty, like, that's not a long time at all. Nobody's been to Mars yet, like a physical person, right?
No.
I wonder why. It's not because they'd be crushed by the gravity, because they could literally just like, yeah, gravity be like
It'll be kind of like the moon almost, where they have a slight, like they walk around and kind of go boom, boom, boom,
Now, I did see an article one time about building like things on Mars, like buildings in a fast way, right? And one of these concepts that I seen, it was really brilliant, because what they did was they took like this inflatable dome, right? And you think, oh, an inflatable dome that would get punctured and all this stuff, right? But what they did was they used the inflatable dome as sort of like it's like a skeleton almost. And what they did was they put concrete over top of this inflated dome, right? And they formed the building shell using this inflatable dome, and then they deflated the inflatable dome after the concrete had set. right? So they had a strong rock building made very quickly out of this inflated dome, which is really cool. It was a concept that they were thinking of doing to make buildings on Mars for habitation. Let's see if I can find a picture of it, because I'm not doing it justice.
In the meanwhile, I'm cooking tacos.
Oh, nice. I think those might be it. Yeah, this is pretty much it, I guess. No, that's not it at all. Hold on. Okay. Alright, so this is, I wish I could get it bigger, but this is pretty much it. Take the pool away. So what they do is, are you able to see my mouse too? Or no?
Yeah.
No. Yeah, you can see my mouse right here now?
Yeah.
Okay. So what they do is they'd inflate this dome, right? And then they just pour concrete over top of it until it solidifies and it have the shape, and then they deflate the dome, right? And then they just move it to another location and make another one, right? And they would just continue to do that, and they would have these concrete like buildings that you can like put like glass in and or whatever, and it would be you'd be able to have it inside like shelter. I think it was cool.
That kind of reminds me of this plumbing technique that they do, where they douse this like thing in epoxy, and they what they do is they run it through pipes, and they basically reline some old pipes using this new pipe that's doused in epoxy, and when the epoxy hardens, they cut it off, and it's a new lining for the inside of the pipes.
Huh. Well, that's cool.
Yeah.
Here's another one.
Oh, cool.
But it's just fast. It's just fast building. And it's effective.
Oh, yeah.
Yeah, it's very effective. So let's recap here. We've got the atmosphere issue pretty much solved. We've got vegetation solved. We've got algae and the silica issue pretty much solved. We've got this crazy glitter that we could use, that those scientists were thinking about to warm up the atmosphere. So that will help with the algae and the moss, right? And
Yeah.
and it should bring up water. And what else? I wonder. Oh, and that wormhole, or not the wormhole, the black hole. But how do we harness the energy from that? You're saying mirrors?
Some type of thing like mirrors.
Huh, let's see if I can find. I want to ask ChatGPT about it.
Hear that sizzling?
I'm just going to copy what this says in the article. I'm going to put it in ChatGPT, and then we're going to build upon this to see how... I want to see how we harness the power of this thing. Alright. So now, like, how do we harness the power? So harnessing power from a black hole, particularly a small one, as proposed by Avi Loeb, involves several theoretical and practical challenges. Here's a conceptual outline of how one might theoretically harness such power, keeping in mind that this remains speculative and beyond current technological capabilities. We'll see. So generating a black hole, antimatter production. One proposed method involves using antimatter to create a small black hole. Since antimatter is extremely difficult to produce and manage, this step alone is a significant challenge. Advanced civilizations might use high-energy particle collisions or other theoretical means to produce black holes. Well, we've got, like I said, the Large Hadron Collider. Black hole formation. Alternatively, black holes could be created via high-energy collisions in particle accelerators. However, the energy required to create even microscopic black holes is immense and beyond our current capabilities. No, it's not. They've actually done it. I'm going to show you right now. CERN created a small black hole.
I think they use lasers to do that. Right?
Oh, there's an article I read. Like they've created, I read one about a tiny black hole. Like it was very tiny and it only lasted a second because there wasn't enough mass.
Tiny? Like,
Yeah,
how tiny are we talking?
Like, way smaller than a pinhead.
Oh, wow.
There's definitely... So, this guy named Jeff Steinhauer, I'll show you this. Fine. Wired, you're killing me here. Okay, I'll just read you the headline from this screen here that I've got. All right. So this guy named Jeff Steinhauer, inside his lab in Israel, Jeff Steinhauer crafts microscopic black holes. These objects are but humble specks, lacking the spaghettifying suction strength of an actual dead star. But Steinhauer, a physicist at the research university Technion, assures me that he's constructed them mathematically to scale. And of course, Wired won't let me read more without the subscriptions. But so if we're able to make a tiny one, like I did see an article recently that I'll have to try find it for our next stream. I won't be able to find it right now. We do got to wrap up here in a few, like maybe 20 minutes or so. But we could probably hop on again after. So what are your thoughts thinking, just me reading that, Mike, about the scientist in his lab in Israel has created microscopic black holes?
I think that a lot of people might be afraid of that.
I felt a little fear at first too, because there's a lot of, we'll call it misinformation, but not at the same time. Like they go on about the scariness of a black hole, but they've got to be a certain size in order for them to be dangerous, right? And
yeah,
if you look at how long it actually takes for a black hole to grow to the size that it needs to swallow us up, takes billions of years essentially.
oh yeah.
Like it doesn't happen and it just grows and grows and grows. The more it eats, and like we've got this kind of fear that like this black hole is coming for us, right?
Well, I think that black holes are only as dangerous as the size that they are, I suppose.
True. Well, I mean, they're huge, right? They're big. But, like you said, they're only as dangerous as the size they are.
My thing is they're trying to take a black hole and make it a moon, like something that orbits the Earth, and they're trying to harness energy out of it.
Right.
So, the thing is, we need to figure out how to harness that energy before we even create it.
Well, I think we've come into this sort of idea on where to start. Right? Like, so with this right here about how to harness right here. How do we harness? So radiation to electricity. Technologies would need to be developed to convert the high energy photons of Hawking radiation into electrical power. This could involve highly advanced photovoltaic cells or other energy conversion technologies designed for extreme conditions. Energy storage distribution. Once converted, the energy would need to be stored and distributed effectively. This could involve advanced energy storage systems capable of handling vast amounts of power.
Love you.
Uh-huh.
Yeah, so the risks associated with manipulating black holes, including potential catastrophic outcomes, would need to be carefully assessed and managed. Well, I mean, we could probably start trying to figure that out. Right? Like, there's got to be something where we're able to receive the power that's generated, store the power, and distribute the power.
Absolutely.
And I'm thinking like something similar to a solar panel.
Something that captures the light and stores it into a battery.
Okay, well, we're essentially we're just going to loop into a Dyson swarm. Right? We're just gonna end up going to a Dyson swarm as our solution, or a Dyson sphere, right? So essentially, what we've got to do is create a black hole, create the Dyson sphere around the black hole, feed it matter, and get the energy it produces. So, do we know how to create a Dyson sphere?
Yeah,
We
to
do.
some extent.
Show me how to create a Dyson sphere. This thing might. Crafting a Dyson sphere, a hypothetical megastructure designed to capture a significant portion of a star's energy output, involves enormous scientific and engineering challenges. While constructing a full Dyson sphere is far beyond our current capabilities, we can outline the theoretical concepts and possible approaches. So there's different types. There's like a Dyson swarm, right? Like you were talking about. Then there's a Dyson shell, a solid or semi-solid shell completely surrounding the star, capturing most of its energy. This is a more advanced and speculative concept. Then we've got a Dyson bubble, a system of spacecraft or mirrors, here we are, in a stable orbit around the star using radiation pressure to maintain position and capture energy. That probably would be the easiest out of all of it to start with, wouldn't it?
Or the Dyson swarm.
Well, we already... a system of spacecraft or mirrors. Well, the mirrors would be easy for us to make, right? It's just polished metal, right?
Right.
Dang. So, yeah, the mirrors. Like, so essentially we could think combining a solar panel principle to this mirror Dyson bubble sort of thing would be a healthy way to start this. You know, I'm probably going to have to... I think it might be cool to create some visual concepts when we're talking about our things. Right?
Right.
Like creating a black hole, maybe in like Unreal Engine or something, and showing, you know, the planet beside it, and then creating that Dyson swarm around it, and then and showing the principles of these things. You know what I mean? Or showing a simulation of how terraforming Mars would look. I think that'd be cool, wouldn't it?
Yeah. That would be pretty cool.
I mean, it would be a way to utilize some of the skills that we have here at Saving the Universe with ChatGPT. So right now, I think maybe it might be good for us to bid everybody adieu for the day, and hopefully that our conversation is stimulating and gets everybody's brains surging in a way that's productive towards a better future and advancement, and maybe some things that people haven't thought of before, or confirm some things that they've already been thinking, sort of like what happened to us today, because everything we were thinking, somebody else had been thinking as well. And that means that we're on the right track, and you are too. We're all on the right track, essentially. If you're thinking it, someone else is thinking it, and we might as well come together and think it together. And
absolutely,
maybe make it happen someday. So this is Saving the Universe with ChatGPT. Thank you everybody for watching, and we will bring you exciting new information to tickle those curious brains you have. Would you like to say some parting words, Broadband?
well, I hope, like Knuckles said here, I hope that this was stimulating for everybody, and I hope that, you know, we can come together as a civilization to try and save the universe.
I agree. We will save the universe with ChatGPT and everything that comes after. Thank you everybody for watching, and make sure to hit the like button, subscribe to the channel, and put on the notifications, because we'll be back.
Absolutely.
Adios.
Adios.